Hello, Algebra 2. Hopefully you have been doing well. This was planned for the first day of school, but I think, we've had a few weeks to just hang out. Let's get started on it now. So, this assignment, which is going to be available on Google Classroom, I will post it later. It's going to look like this. Woohoo! If you complete all of that in its entirety and you email it to me, using this title, if you want to say algebra2.lo1. And then your last name and your first name. Email it to me, scan it, take a picture, upload it to Google Docs. However you want to do that, that's fine. That assignment is going to be considered a replacement grade. So if you do that and turn it into me, complete it in its entirety, I will replace your lowest homework score. So if your lowest homework score is a 3, I will go and replace it to a 10. 10 out of 10. If your lowest homework score is a 0, if it's a missing assignment, I'll just go replace a random missing assignment. If your lowest homework score is 9, I'll just replace it to a 10. Okay? This assignment is going to be a homework replacement. Also, it's good review because this is stuff that we're going to be using when we come back and get ready for school, whether that's in the classroom or online. We will see. I am going to go through the first column. I'm going to go through this part with you. So half of it's going to be done, and I'm also going to go through this part with you as well, so you have examples to look at. So all of these are written in black. Again, this is following from the papers that I would hand out or that is available on Google Classroom. I'm going to put my answers in red so we can go through it together. The first question asks us to write the exponential equations in logarithm form. So we had log, we usually had a base, we'll just call it b, of some number a equals c. And again, if we want to go back and forth between these two forms, logarithm and exponential, we could say we have a base b has to be raised to some power of c that gives us this number a, whatever a may be. So let's take these exponentials and write them in logarithm form. I have a base of b, so I'm going to say log base b of 99. Oh my gosh. Log base 5. Good morning. Alrighty. Log base 5 of 99 has to be equal to this exponent of x. Okay? So that's how we could go back and forth between our exponential and our logarithm form. Down here we have a base of e. That's a little bit different. We have our exponent of 2 equals k. So I'm going to write this two different ways. I'm going to say log base e of k equals 2. And since I know that we have a base of e, I could write this as a natural log. So I'm going to say natural log of k equals 2. And we would usually prefer it to be written like this with natural log. Let's do one more. Base of 4. So I'm going to start this out. Log base 4. 4 is being raised to a power of 2 equals this 16. So log base 4 of 16 has to be equal to my power of 2. That's going back and forth between our exponential and logarithm form. Let's reverse that now and take our logarithms and write them as exponentials. Again, this is just from the worksheet that I have. So log base 4 of 51 equals x. So I've got that base of 4 has to be raised to a power of x, and that gives us 51. Again, I'm just following from, there it is, following from this right here. It should be in your notes. It's in your textbook. Make sure you have this written down somewhere. That will help you. Okay, let's keep going. ln natural log of 4 equals p. Again, what do we know about natural logs? They have a base of e. So I have base e being raised to my power of p, whatever that number may be, equals 4. Again, even though there's variables, we're still just writing these in our different forms so we get used to this. And now I have log base x of 3 equals 8. So my base of x being raised to the 8th power equals 3. All right. Let me know if you have any questions. Again, email me. Just shoot me an answer or shoot me an email. Okay. Now we're going to evaluate the logarithms using change of base formula. This is where you're probably going to need a calculator. So we had change of base formula. Basically, we're going to pick a new base, and we're going to be dividing some stuff. And we're usually going to pick a base of 10, since our calculator works really well with calculating base 10. So the change of base formula goes as follows. It takes this thing, which is, I don't know what that number is. I could plug it into my calculator as log base 10 of 51 divided by log base 10 of 4. Again, base 10, we could just write these as common logs. Log 51 divided by log 4. And if you plug that into your calculator, we're going to kind of round these off. It was 2.836, so we'll just call that 2.8. The question asks us to round to the nearest hundredth on the paper. Let's do the same thing with this one here. So, again, we can see that we're taking we're taking this number and dividing it by this number with our log base 10. So, again, we're just kind of going through these motions. It's log base 10 of 64 divided by log base 10 of 2. Again, these are just common logs. They're just log of 64 divided by log of 2. You plug that into your calculator. Make sure you're closing the parentheses on these here. So you plug it in as log 64 close parentheses divided by log 2 and then close parentheses. And actually that's going to get you 6 because, well, we know 2 raised to the 6th power is going to give you 64. Last one here, again, log base 10 of 51, just using that change of base formula, divided by log base 10 of 6, log base 10 of 51 divided by log base 10 of 6. Again, you plug that into your calculator, you're going to get 2.194. We'll round that off to be about 2.2. Okay. Now we're going to look at solving some exponential equations. I do have some videos of this on my previous YouTube postings, whatever. I'll go through a couple. Again, these are going to be very similar to the ones that I'm going to ask you to do on your own. So first, I'm going to divide by 2 on both sides. So that's going to get rid of my 2 here. I'm just going to be left with 3. Oh my gosh. Again, good morning. 3 to the power of x equals 125. And now I can ask myself, can you write this as a logarithm? Because 3 to the power of x equals 120. I don't know what x is right now, right? I got to use the change of base formula somehow. And in order to use the change of base formula, I'm going to have to put it into a logarithm equation. So I'm going to say log base 3 of 125 equals x. And then I can evaluate this. Well, it's just going to be log base 10 of 125 divided by log base 10 of 3. Again, using that change of base formula. Plug that into your calculator. Log 125 close parentheses divided by log 3 close parentheses. And you get about 4.395-ish. All right. Couple more. Now I'm going to flip it over to the back side. So in order to solve this, I'm first going to minus 15 from both sides. Again, we're just solving it like a regular exponential, or like a regular equation. We'll take care of the exponential and logarithm later, right? So minus 15 from both sides, you're going to get 4 to the power of x equals 165. Again, let's write this as a logarithm equation because I'm probably going to need to use my change of base formula. So as a logarithm equation, this thing is going to have a base of 4. 165 equals x. Use the change of base formula to evaluate what this is. Well, that's going to be log base 10 of 165 divided by log base 10 of 4. And that will get you something that's close to x. So again, plugging that into our calculator, getting a rough estimate, x is going to be about 3.6831. All right. So up here we had to divide by 2. Down here we had to minus 15. We're going to kind of put that all together. Now I have multiplication and some sort of subtraction or addition, right? So I'm going to add 20, just like we've been solving equations since the dawn of freaking time. Adding 20, that gets you 198 on this side. We're going to divide by 3 until we see that nice exponential equation. What do we got? 198 divided by 3 is 66. Now I have 8 to the power of x equals 66. Again, whoops, eraser, no, okay. Again, can you write that as a logarithm equation so that we can solve for what x is or get a close approximation? So I'm going to say log base 8 of 66 equals x. And then to evaluate that, use your change of base formula. So x is approximately log base 10 of 66 divided by log base 10 of 8. All right, and then that's about 2.01479. All right, that was a lot. You did great. If you can do the other half of this worksheet by yourself, I would very much appreciate it. Again, it's all the same stuff that we just did here. Now you have examples. Access this on Google Classroom. Send me an email if you have any questions. I will do my best to answer it. Again, this is a grade replacement, so if you are missing an assignment, if it's a 0, I'll just go through and replace it with a 10 if you complete this. If your lowest grade is a 3, I'll replace it with a 10, all right? This cannot hurt you. Please, please do it for good practice. Keep your skills in top shape, tip-top shape. All right. Have a great day. See you later. Man, clocking in at about 12 minutes. All right. I just want to make sure that everyone knows exactly what I'm talking about when I say change of base formula with our calculator. And I want to show you how to evaluate it real quick. So if I want to figure out what x is, this was from our last problem, the last one that I did on the example in the video. So log base 8 of 66, all I'm doing is using this log button right here. And I'm saying log of 66, and then close parentheses, using that button right there, divided by log of 8. And then I like to put a close parentheses on the end again, and then I can hit enter. And that will get me that number that we came up with in the video, 2.0147. And basically what that's saying is that 8 raised to this power should give me 66. So if I do 8 raised to the power of my answer, okay, 8 raised to the power of 2.1 or 2.0147, yada, 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 I should get 66, and I do get 66, all right? And even if I said 8 raised to the power of, I'll just kind of cut it off at 2.01479, I get 65.9999, which is going to round up to 66. All right, make sure you know how to do that. Don't forget your close parentheses.